Welcome to the first part of the feedback then on the coastal landscapes in the UK section. There'll be a separate video on the second half of the rivers bit. Okay, so the first question then, or the beginning of the assessment, asks you to have a look at figure 11, and it says they're part of the coastline of southwest England, shown on a 1 to 50,000 ordnance survey map. Look down here, there's our map of the area, and we've got our grid references along the bottom and along the side. Okay, so let's have a little look at the first question then. So the first question then said for us to give the 4-figure grid reference for that square that contains Elbury Cove. And actually, if you notice here, this student's made this most common error that a number of you made, which is that you've done it the wrong way around. It's x-axis first. That's basic stuff, guys. Okay, but quite a lot of you were doing that the wrong way around. So you got the right answer. You knew what you're doing, but you've put it on the side. So Elbury Cove is here. So we go to the bottom left corner, we go down, so the first number is going to be 90, and the second number is going to be 57. Okay, so 9057. Now, the other mistake, other than this one here, the flicking it round, was people were writing 6 figures. You can't get a mark. It doesn't ask you to write a 6-figure grid reference. It asks you quite clearly to give the 4-figure reference. So if you give a 6-figure grid reference, even if it's more accurate, it's wrong. It's the wrong answer, so you'll get 0. So be really careful. You must read the questions carefully and do what it says. I'll probably keep saying that as I go through this. Okay, next then was this one about the difference in the 2 spot heights. Okay, and the correct answer was 91 meters here. So if we have a quick look, then it's 914542. So 914542. So here, look, we have a spot height there of 150 meters. So 150, there's the dot that shows that. Okay, or in fact, it might be at that point there, but it's 150 meters. So that's our first one. And the next one that we needed to look for was the golf course at 908568. So 90.856, there's the golf course there. Okay, so there's the golf course, and we've got then 59. Okay, so we've got 150 and 59. So quick bit of maths on that. The difference between the two is 91 meters. Okay, next then is study figure 12. Okay, so you had to look at this photograph here just to see what we were looking at. And it said it was the photographer facing northeast, and it tells us he was at 931, or she was at 931,549. 931,549 facing northeast. So let's go back to the map. Okay, so 931,548 was it? Something like that. Anyway, it's here. Okay, so this is the location where that photographer is standing. Okay, and they have taken a photograph looking to the northeast. North, never eat shredded wheat. So northeast is going to be in this direction up here. So we look out, the photograph looks out across a bay, doesn't it? You've got a bit of a beach, then it goes to the rocks, and then we see a headland. And the headland there is Dirl Head. Okay, so the correct answer here is Dirl Head. All right, so Dirl Head. Okay, there we go. That's got that one correct. Next then is suggest one reason why the headland and bay shown in figure 12 have formed on this stretch of coastline. Most of you got this idea that it's bands of hard and soft rock, isn't it? So hard and soft rock, and the soft rock has eroded faster than the hard rock. Okay, it was only a 1-mark question, so it was quite flexible on what you could get there. But you do need to have sort of commented on it's the rock type and the fact that it's softer rock having eroded faster than hard rock. Okay, right, next question then was which of the following coastal processes are not likely have contributed to the formation of the headland in figure 12? So the headland is the sharp rocky area, isn't it, which is going to have had rockfalls, okay, which have created that very steep slopes. Hydraulic power from the waves coming in and crashing into it, they're going to have smashed into that headland, aren't they? And that's what's going to have caused the rock falls, caused it to collapse. Longshore drift, which is the correct answer here. If it's the headland, longshore drift isn't relevant. Now, if it had said the bay or the beach, then we could have maybe talked about longshore drift. But longshore drift is the movement of small sediments, and that's not what the headland is. The headland is a steep, sharp cliff, basically, going out to sea. So that's going to not have been relevant here. Mechanical weathering, obviously, the headland will have had freeze-thaw weathering occurring on it that will have broken parts apart and knocked it down, that kind of thing. So definitely mechanical weathering will have sharpened and taken bits of rock onto the ground. Obviously, the mechanical weathering links to rockfall, and the hydraulic power will be crashing into there as well. Okay, so correct answer there, longshore drift. Not relevant really for a headland. That's a bay, isn't it? Okay, next question. Now, this one caused a little bit of issues in some ways, in that the question says, suggest how the coastline shown in figure 13 may change in the future. Well, this is the beginning, or basically this is the start of a series of diagrams that show the formation of a spit. Okay, so you've got the direction of the prevailing wind, so you've got zigzag motion here with the material being picked up, taken out, picked up, taken out, picked up, taken out. It's then over time going to start getting deposited here, and we're going to then start to get a spit, okay, going out. Now, the thing is with some of your answers is that you didn't really talk about, sediment being picked up and moved. When all of these questions, the way that they're wording them, all that they really need you to do is say the stuff that you've been learning. You've learned how a spit is formed. You could have drawn a series of diagrams to answer this question. I know using the computer that's tricky, but that would have been perfectly fine to sort of predict it. So sediment will be picked up, taken out, so picked up following the direction of the prevailing wind. It will be deposited out across this bay area, okay, as the coastline has changed direction, and you will form a spit. Okay, you could then comment on, I think only one person commented on the spit curving, okay, having that recurved end. And quite a few of you did suggest that perhaps it could eventually reach across to the other headland here to form a bar, which is absolutely true. Now, we don't know whether there's a river flowing through here or not, so it's perfectly acceptable to say that. And therefore, behind here, you would be getting a salt marsh forming up. And if it becomes a bar, then it could be a lagoon forming there as well. So there's some of the things that could change. Okay, but you must remember when you're answering these questions, just use what you know, the sort of core knowledge, the things that we've learned about. The formation of a spit. That's all it's asking you to do, is tell them about the formation of a spit. Okay, right. On to the next one then. So this one then, study figure 14, a photograph of coastal defences at Caerleith in North Wales. So most of you then identified. Now, just a couple of you never mentioned figure 14 in your answer. I mean, this has got to be an absolutely essential part of when you do any question like this. The first words I would have at the beginning here would be in figure 4. Now, it's written down here, so that's fine. But you must make sure it says the first 3 words of this question using figure 14. The examiner is not there to guess whether you've used figure 14 or not. The examiner is there to mark where you've shown them that you've used figure 14. Okay, so make it obvious by saying in figure 14, as is done down here. So we've noticed that there's a wall, sea wall, and there are groins. Okay, in figure 14. I can't see any other hard engineering features here, so I think it's just those 2. But it does say here, and your own knowledge explain the costs and benefits of hard engineering strategies for coastal management. So perfectly fine to talk about rock armour or gabions. Okay, so this question then, what you need to be doing is you need to be commenting on the costs and benefits. And most of us got the idea. I think we did follow this. We said, that the seawall was very expensive. However, the benefit of it is it does prevent sort of the flooding, and it prevents the waves from being able to reach the houses and causing, even more expensive sort of damage. Talked about the groins. Wasn't quite as good the answers about the groins, but the groins are trapping the sediment, aren't they? They trap the sediment here on the beach, which builds up the beach, which reduces the energy of the waves, and so therefore there is less erosion going to be taking place in this area here as a result of a wider beach. Some people talked about that, making a wider beach good for tourism, protecting the tourist industry and so on. Perfect, yeah, no problem. They're the benefits of it. Costs, obviously, they're quite ugly, they get damaged, and there's a financial cost to having them as well. Also makes it difficult to walk along the beach with all these groins in place as well, doesn't it? So that's a negative. The seawall, obviously, the sort of negative side of it being very expensive, but it does create a sort of area for tourists to maybe walk along in some places. And you could, as your own knowledge, you could talk about Hornsea here. Okay, so if you talked about Hornsea as a sort of way of you adding in some of your own knowledge here, that would be a good idea too. Okay, right, on to the next question then. Following complete the following three sentences. Okay, so erosion and weathering break down rocks in coastal area. Weathering and erosion. Erosion, the movement that breaks things down. Weathering, in situ, where it stays still. Okay, usually by the weather, hence the name. Next is sediment is transported by the action of the waves and tides. So it's moved along by waves and the tide. So that's transportation, movement. And the last one then, once waves and tides have lost energy, deposition takes place. So when the wave loses energy, then material is then dropped off. Okay, and that's what happens. So we've got deposition, dropping off of material when the waves lose energy. Okay, next one. I think everybody's difficult sometimes to tell with these, but I think everybody got these correct. So nice and straightforward, these, aren't they? Okay, so you just had to name the four different ones. So A was your arch, B was a cave, C was the stack, and D was the wave cut platform. Perhaps if it was just asking you what was D, that would be a bit harder to tell, wouldn't it? But obviously there used to be an arch here, and underneath the water there would be a wave cut platform. As this, there's not a lot to erode that away, is there? So, because the waves are what erode it, aren't they? And it's under the wave height. So yeah, there'd be a wave cut platform there. Okay, so we'll scoot past these ones here. So I think most people got those ones right. Okay, on to this question here then, which says study figure 11 of photographs showing storm damage in a coastal area. And the question asks, suggest why the coastal area shown in figure 11 needs to be protected from the effect of physical processes. So there's a couple of things to identify here. Number one, it's right by the coast, okay, and has been in the past or has been recently affected by coastal erosion, by waves, hasn't it? So that's the first thing, is it's at risk, okay, it's an area at risk. The next thing is to talk about, well, why do we need to protect this area at risk? So this area has, number one, got a railway link, okay, and that is important for the economy, okay, so economic factors in terms of people accessing work. Quite a few people mentioned bringing tourists into the area. That was a good answer. And people getting to work, but also goods and transport around. So that's the first thing, is to sort of talk about the economy linked to the railway. Okay. Obviously, it's going to take time to repair this. People aren't going to be able to get to and from work, and to and from business is going to be much harder, isn't it? The other thing then is talking about in the background here, talking about is where people live, it's their homes, and so there's going to be high cost if these areas collapse. So it's kind of about, it needs to be protected to prevent future costs of having to replace these houses or people having to move. Okay. There was also a couple of other things people mentioned, things like danger, that it's a dangerous area, so it's at risk of collapsing and could cause loss of life or whatever. That's fine as well. But the key to this question is to make sure your focus is all about, is linked back to the physical processes. Okay, so it says protected from the effects of physical processes. You've got to say that waves on the sea could come in and attack this area. This will mean that the economy struggles because the train lines can't run, so people cannot get to and from work. Something I've sort of noticed as I've gone through this with a lot of your answers, not everybody's and not all the time, is that there is a tendency to write very, very short sentences. Okay, you should be writing linked sentences, sentences that then go on and add something to it. You know, you spend a lot of time in English constructing, don't you? Constructing sentences. The reason you construct sentences in English is so that when you write your answers in geography or in other subjects, they're more complex. The language and the way that you're writing is more complex. And I think as something we have to recognize is that in order to get the very top marks here, that linking of sentences together, that complexity of language is key. Okay, so even when you've got so some of you have got all of the things that I've just said, but you haven't put together a clear, well-written answer. And as a result, you know, you're not going to get the very top marks. You'll still do very well, but it's not quite going to get the top marks. So just be careful about that. Do remember, you know, how to write. You do it all the time, don't you? And you write, you know, in detail. You need to be doing that in your exams. Okay. Obviously, it was a bit different having to type as well here. I recognise that. Sometimes I think I certainly, if I'm typing, my flow isn't as good as when I'm handwritten. So some of you may have struggled a bit with that, which is fine. That doesn't matter. But definitely a point to remember there. Okay, moving on then. Next one then, study figure 12, a photograph showing soft engineering. Again, just a reminder, figure 12, you've got to talk about it. You've got to say in figure 12 there is a digger, which is, so to talk about what's going on here. So soft engineering, I mean, the key things here was your beach regeneration, and beach nourishment, and beach reprofiling. Okay, there would be the two things that are clearly identified here on figure 12. Nothing wrong with talking about other soft engineering features. It does say you can do that. So what you'd want to be doing here is saying in figure 12 there is a digger which is moving sand around on the beach. This is a form of soft engineering. Probably that material has been added to the beach by a dredging ship such as they have at Pevensey. So notice how I'm putting in my own knowledge here as well. I'm wanting to get 6 marks, aren't I? I'm not wanting to get 2 marks or 3 for giving the right answer. I want to get 6 marks by expanding my answer, showing my geographical knowledge. So the sand is added to the beach, and this is then reprofiled. Now there was quite a lot of you that talked about making the beach steeper. Now when we beach reprofile, we don't make the beach steeper, we make it a steady slope. If you make the beach steeper like a cliff, then it erodes very quickly. Instead, we have we try and make it a sort of nice diagonal line going back, so gradual line, so that, and this then needs to be talking about as the waves approach the beach, they have to climb gradually, and so their energy is dissipated or lost or reduced. Therefore, the wave has less erosive power to attack or to remove the beach material. It's all about sort of turning a destructive wave into a more constructive wave, reducing its energy. So therefore, you get less erosion taking place, less movement of the material. Okay, so just be careful there. Quite a lot of you talked about making the beach steeper. That isn't what you do. You don't want to make a beach steep. You want to make it a nice gradual slope. Okay. You do want to build up the beach with more sediment on it. Okay, that may be what you were referring to, building up the beach with more sediment. Okay. So that's what you've got to talk about here. So, you know, in figure 12, they're building up the beach. And they reprofile it to make it a nice gradual slope, so that when the waves do come, when there's heavier wind, the waves are slowed down and the energy is reduced from them. Therefore, there is less erosion and less material is taken away. This is a form of soft engineering, as it matches the nature's way of preventing erosion. Could then talk about dune regeneration, so this could be added to, you could put plants in and so on to build up dunes, which locks the sediment sand together, making it harder to erode. And yeah, a couple of people mentioned managed realignment as well, which is a soft engineering technique. So you could talk about that, allowing the land to be taken over. But there's no particular need. It's kind of drifting a bit away from the question there, but nothing wrong with it. But I would stick with giving lots of detail about how beach nourishment works, how beach reprofiling works, and linking it to what I know about Pevensey. They would be the things I would be doing to get my 6 marks. Okay, scroll down. Okay, that is the end of the first video.